Hello, my name is Myra Puyol. Today I will be presenting my assigned drug from this semester, which is Marinol, or also known as THC. So, a brief history. Marinol is a drug that has dronabinol as an active ingredient, also found in THC, and is under drug class Schedule 3 under the Controlled Substance Act. Some trade names include Syndros, Reduvo, and Adversa. This drug can only be purchased with a prescription, and is considered illegal to buy without one. So uses of Marinol include it's used for patients that are going through chemotherapy, so it treats the nausea and vomiting associated with it. Marinol can also be used to treat weight loss and appetite loss for people suffering with HIV infection. So the mode of action, this could be administered orally and has complex effects on the central nervous system. It may also inhibit endorphins in the emetric system, suppress the medullary activity, and suppress prostaglandin synthesis. Dronabinol is a light yellow resinous oil that is sticky at room temperature and hardens upon refrigeration. It is also insoluble in water and is formulated in sesame oil. The pKa is 10.6. So some side effects include abdominal pain, dizziness or lightheadedness, confusion, feeling high, and it can still cause nausea and vomiting, but these side effects usually occur when the body is trying to adjust to the new drug. So one alternative is Sesamet, also treats nausea and vomiting associated with chemotherapy, and the difference is this is under Schedule 2 in the Controlled Substance Act. So this medication is usually just administered if other drugs have not worked. So right here I have my expanded structure kind of QR code. So having to come here, right here is my expanded structure. Here you can just see the hydrogen bonds to the carbons and some lone pairs. There would be two lone pairs in this alcohol group and one more pair on this oxygen. Now going back to the presentation. Moving on to functional groups in Marinol. So these include alkane, phenyl group, and other. Here I showed the little images. So the phenyl right here is located right here, and then the other on this oxygen. This alkene would be right here with the double bond, and the alkane would be this chain right here. Moving on to VSEPR geometry, I added a color to each geometry. So trigonal planar is kind of located on these rings. And then tetrahedral on this chain and these carbon groups. The bent 109.5 is right here with the alcohol, and the bent 120 is on this oxygen or other group. So hydrogen bonding within marinol and hydrophobic regions. So here is a very large hydrophobic region indicated with the pink. And then I added 2 of the hydrogen bonds onto those molecules. So polarity and solubility. So these green arrows indicate all the polar bonds, which is with the OH and the CO bonds, since they're under 1.6 in electronegativity. So the arrows also indicate where that polarity is facing. So that means the rest of this molecule is nonpolar. So the solubility of marinol has poor solubility in water for the following reasons. So the molecule is large, making it hard to be soluble in water. There are significant nonpolar bonds, only being 4 polar ones. And marinol is not an ionic compound. So protein bonding. Like said before, marinol does not participate in ionic bonding because it is not an ion, nor does it contain ions. So right here I have an H bond with a asparagine, which that connects to a protein bond right there. Next is chiral carbons in marinol. So marinol only has 2 carbons that have 4 different groups located where the teal boxes are. So changing pH, low pH conditions, this molecule stays the same or as is. And in high pH conditions, the structure turns into its conjugate base form. And that is it. Thank you for watching.